Hi, welcome back to my channel. So in this episode that I made about 1 month ago, I tested this amplifier here, which I bought from eBay, and I thought it was a ZFL1000 amplifier. Instead, by inspecting a little bit the label and the performance of the amplifier, I realized that it was actually a very similar model, but it's called ZFL1000VH amplifier. Okay, and it turns out that this is quite a bit more expensive, so it's a good model to have. So I'm very happy I bought it for just 30 euros, and probably also the seller didn't realize that it was a VH amplifier. And so yeah, when I discovered this, I decided to make basically a simple enclosure to this amplifier to use it more frequently in a simpler way, so with its own power supply, linear, and just input output and on off button. Okay, and so basically today I was kind of testing um, let's see here if I can show it to you. Yeah, the specifications of this amplifier, and everything is as in this datasheet. And in particular, in this video, I would like to discuss this IP3 element, this IP3 information that, as you can see here, for this amplifier is supposed to be 38 dBm. So I just want to explain very quickly, basically to myself for the future, what this means, because it's pretty simple, but it can be Wikipedia is if it's formulated it is a bit in a bit mathematical term, so I think it can be presented in a very simple way. So here, as you can see, at the moment I have so let me see, I have my signal generator emitting a signal to the amplifier, and well, let me, it's basically there, right? So so the signal generator is going to the input, and the output is going to the input of the spectrum analyzer. And as you can see here, we have the signal generator is producing two tones, one tone at 14 megahertz here, and the other tone at 14 megahertz and 1 kilohertz. So the two are 1 kilohertz apart. Okay, and so at the moment I'm emitting from the signal generator, so each tone has 15 dB of power, and so here, as you can see, we basically have 7 dBm of output, so the amplifier is amplifying by about 22 dBm. So let me show you what happens if I start increasing here the power of the input. So if I increase it just a little bit, as you can see that the power is going up as expected, and I can continue, the power is going to increase as well. But at some point the amplifier is reaching its limit, and it will amplify the signal, yes, but it will also introduce some distortions, and let's see them, they should appear more or less now. So still the distortion are very low, but let me increase. Yeah, now they are more apparent, right? So the first distortions that we have here, this first peak, I mean, all the distortion that we have, a peak here, are generated by the intermodulations of the two main signals, okay? But the first peak is called a third order intermodulation product. That's just the technical name that it has. And yeah, it is this one, and the value, the IP3 value that we're going to talk about is related to the value of these harmonics, basically, of this distortion. So something to note here is that if I increase the power just by 1 dBm now, so as you can see, the distortion grows much faster than the actual the two main carriers, right? So let me increase it just 1 dB more. So as you can see, the distortion grows faster than the carrier, and in fact this is a known fact. Let me show it to you on a graph here. Or yeah, before moving to the graph, let me set the signal generator as it is right now to 0 dBm, and let's measure the power of this third intermodulation product. So it's about, let's let it do a couple of sweeps. It's about 6 dBm, okay? So here I've printed here on a piece of paper, since I'm terrible at making diagrams. So let me disable the HP here. The situation. So here on this line, we have our amplifier. Okay, so it's amplifying 22. So I hope you can see sufficiently well. It's the amplifier is basically taking its input and adding 22 dBm. So both on the horizontal and vertical axis, we are like so the horizontal axis is the input in dBm, and the output is also on the vertical axis in dBm. So when the input is minus 22, the output is at 0, as we expect. This is the behavior of a plus 22 amplifier. And when we are at the input is 0, we expect plus 22. So ideally, the amplifier acts as this straight line, right? And here we have the situation of this third intermodulation product. So we are just depicting the strength of this intermodulation product given the input power. And we just measure that when the input is at 0, we have about minus 6 dBm of power. Before I measured 6.2, so I depicted the graph this way. But anyway, this point is minus 6. And the fact that, as we observed, these intermodulation products grows faster, so the slope is faster than that of the amplification of the main signal. It's in fact 3 times faster. Okay, so the slope of this line here is 3 to 1. So for every dB of input, we get plus 3 dB in output in this intermodulation product. And basically, what is this IP3 data here is the number, is the level of power that we would have to achieve theoretically. We don't need to go there in practice, but just following these lines, to achieve in such a way that this third harmonic, basically this third intermodulation product, reach the same power outputted to the main carriers. So going back to the HP graph here, is basically if I keep increasing the power, we are trying to calculate the point where basically this intermodulation product catch up with the main carriers. Okay, so it's kind of simple conceptually, and that's it really. So once you know that, you can from the IP3, and knowing this IP3 line goes down with a slope of 3x, you can calculate this line of any amplifier basically. So looking at the data sheet, basically from the gain plus 22 and the IP3, we can draw these two lines, and we can basically predict the level of distortion on the third intermodulation product, which is anyway the largest of all the products, at any given input power. So for example, if I'm driving my input at, let's say, plus 10 dBm, which is here. Also, let's do this example here. This is plus 5 dBm of input power, and so I would expect to see an intermodulation of about 10 dBm there. So let's make this just make this test just to see if the theory matches the practice. So I'm going to move now the let's see. Yeah, so I'm going to increase the power slightly to 5 dBm, and there it is now. And let's see. So the power that we are measuring now at, as you can see here, it's the third order intermodulation is at 8.5, right? Something like that. So let me place the marker even better, maybe, yeah. 8.55. So we were expecting just from a very rough depiction here about 10, and I think we are more or less there. So yeah, it's a very simple concept. It's the theoretical point where this third order distortion, this third order intermodulation product would reach the same power of your actual signal. And from that, by depicting these lines, you can predict the noise level of the distortions. Okay, so that's it for this video. I'll see you next time. Bye bye.